So today's lessons is on graphing linear relations, and we're going to look at the different forms of lines. Now, the math convention for expressing the equation of a linear relation is just simply four different types. There's two different types and then two special cases. One of the special types is called the standard form, and that is anything in the form ax plus by plus c equals 0 or ax plus by equals c. Now, another thing that we want to make sure is we want to make sure that none of the terms, the a, b's, and c's, are in fractional form. So we might have to use an LCM. So we'll make sure that a, b, and c are integers, and we'll also ensure that a is always going to be positive. So we might have to do something simple like multiplying everything by -1. When we talk about the slope-intercept form, we're talking about this equation, where m is your slope and the b is your y-intercept. When we're talking about vertical lines, we're talking about something that looks like this. We're talking about an equation where we have x is equal to a constant. So an example of that would be x equals 3. Now, we're talking about the slope of something like this. Its slope is equal to an infinite slope. Sometimes it's referred to as undefined. Okay? When we're talking about horizontal lines, we're talking about any equation where we have something that looks like this. And an example of that would be y is equal to a constant. So say an example would be y equals 5. Now that produces a horizontal line, and in this case, our slope m is equal to 0 in that regard. Very important concepts to understand, guys. Now, what we're going to do is we're going to move on to example 1. Example 1 is asking us to express each equation in Y-intercept form. So essentially we're solving for y. For question A, we have 3x plus 6y equals 5. So what we're going to do is we're going to isolate 6y. Now that we've got 6y isolated, we need to get rid of the 6. So what we'll do is we'll divide each of the terms that are in this equation by 6 and simplify if we can. Now this can be simplified to -1 over 2, and 6 over 6 goes away, and 5/6 stays the same. And we obtain the following. And we have our equation, y is equal to -1/2x plus 5/6. For question B, we have 2x minus 3y plus 9 equals 0. So let's just isolate the -3y that we have here. In doing so, we have -3y is equal to 2x minus 9. We'll follow the same pattern that we did before. Now we're going to divide everything by -3. Now in doing so, we're going to have some cancellation issues. So y is still left alone, but -2 over -3 becomes 2 over 3. They cancel negative signs to become positive. So we have 2/3 x, but then you have to remember that we still have to use those negative rules. So if we have two negatives in our calculations, we're going to get a positive. So in this case, you got to think of 9 over -3 as if it was being in a bracket. So we get -3, but then negative and negative gives us a positive. So we end up with +3 as our final value in our equation, and there is our solution. So now let's continue with the rest of these problems. So this next problem set is asking us to take something that's not in standard form and put it in standard form. So for this first problem here, I'm going to move all of the variables and numbers to one side and organize them alphabetically from x, y, and then its constant. So we have 3y equals 2x plus 4. So the next line is going to be something which is equal to 0. And what we're going to do essentially is change all the signs of everything. So in this case, now I've got 3y minus 2x plus, oh, not plus, it has to be minus 4 when we move the plus 4 to the other side. Now let's rearrange it as x, y, and then constant equals 0. So we have negative 2x plus 3y, because that's understood to be what's in front of the 3, y, and then minus 4 equals 0. Now, I told you earlier that if I ever found a negative sign on any of my x term, what you want to do is we're going to multiply everything in here by negative 1 in order to flip the signs of everything on here. So basically we end up with the following answer. 2x minus 3y plus 4 is equal to 0. So remember, if there's ever a negative sign sitting on something that you're working with, you want to get rid of that negative sign by flipping all the signs on all the numbers that you have in your equation. So now let's take a look at this problem here. So you'll notice that we have fractions, and I told you earlier that I don't want any fractions on my standard form equations. It's just annoying. So in this case, we're going to have to use the LCM. In order to get rid of those fractions. Now in this case, the LCM for 3 and 5 is 15. So we're going to multiply the top. We're going to multiply everything by 15. Now applying some simplification to reduce our work. So 15 divided by 3 gives us 5, right? And a 1. And 15 divided by 5 gives us a 3. So essentially now we've got 1 times 5 x and a negative sign, which will give us negative 5x. And the second part, we have 4 times 3, which will give us plus 12y is equal to 2 times 15, 30. And now we'll move everything over to the left side. So we've got 0 is equal to negative 5x plus 12y, and then we have minus 30. Now we're just going to flip the signs of everything here, i.e. multiply by negative 1, and we end up with 5x minus 12y plus 30 is equal to 0 is our final answer. Now try to remember that this form that we have for the standard equation is what I tend to expect you to create. When you go off to university and college, most professors will ask you to put it in this form of the standard equation, not the other one, ax plus by equals c. Alright, now let's get on with the rest of the problem set. So now we're going to take a look at this part that talks about intercepts. Now, anytime you're creating a solution to something for a graph, you only need 2 points in order for this stuff to work. Now, if you look at this graph here, you have your x-intercept and your y-intercept. The coolest part about every graph is that all you need is 2 points. Now, let's go through this part of the lesson. It says an intercept is not a point, but it can be represented by a point. Now, on the graph to the left, the x-intercept of, well, if you take a look here, your x-intercept is 2. So we're actually going to write the number 2 here. And it can be represented by the point 2, 0. Now, similarly, you can have your y-intercept, which is represented by negative 4, and that's going to be represented by the point 0, negative 4. Now, when we want to determine the coordinates of any intercepts for a line in this equation, we got to sub basically this. If we want the x-intercept, we want to set y equals 0. If we want the y-intercept, we want to set x equals 0. So when we do these problems, I expect you to label what you're trying to calculate and explicitly state that you're either letting x equals 0 or y equals 0, and then come up with your final solution for your x-intercept or y-intercept. So for this problem here, we have the following. We have 4x plus 7y equals 28. This is how we start it. We label our x int. We state that we let y equal 0. Substitute accordingly. So in essence, when we let y equal 0, the 4x in our equation, 4x plus 7y, just disappears, and you're left with this. No, not the 4. Working through the problem, we get x equals 7. Now, we'll do the same for the y-intercept. So, when we do our y-intercept, we let x equal 0. We end up with 7y equals 28. Work through, and we end up with our y-intercept being 4. From there, you can simply go and graph the 2 points, and then draw a straight line. We'll follow the same template for the next equation, y is equal to 2x plus 10. Except we will solve for x and solve for y. So we start by saying that we're doing our x-intercept, we let y equal 0, and we just substitute directly into our equation. So we get 0 equals 2x plus 10. Now we will move the 10 to the other side, so we get 2x is equal to negative 10. Now we will solve for x. So x is equal to negative 10 over 2. And we find out that our x-intercept is negative 5, which is what we were looking for. We'll do the same for our y-intercept. We get the following. And we end up with our y-intercept being 10. So we're on to part C, methods of graphing linear relations. So basically what we're going to do is we're going to start by graphing with a table of values. So when we're dealing with a table of values, we usually have some form of equation. So here's our equation that we're working with right now. Y is equal to 2x minus 4. We really only need 2 or 3 points in order to graph our equation. And you'll notice that all we have to do is vary the x value. So I'm going to put in negative 1 as x, 0 and 1, all about equidistant apart. When I substitute these things into my equation, for example, if I let x equal negative 1, I'm going to get this as my result. Y is equal to 2 times negative 1 minus 4, which ends up being negative 6 when we do our final calculation. And all we have to do is fill that in our chart. And then we do the same calculation for 0. We end up with negative 4. And then at position at x is 1, we end up with negative 2. So now all we have to do is we have to graph our results on this chart. Now you'll notice how I label the axes x and y. Oops, not y and x. And once I've done that, I expect you to just simply plot these 3 points. So 1, negative 2. Okay, 1, negative 2 is here. 0, negative 4 is here. And the last one is negative 1, negative 6 is here. So all that's left to do is to graph our line. So all I gotta do is draw the line. This won't be very straight, but it is as good as it gets, especially on a tablet. And we get something that looks like this, and then all I want you to do is I want you to label your equation. Y is equal to 2x minus 4. Now, how and why we do this. Basically what you need to do is anytime you got an equation and you want to go and create a table of values, the first thing you have to do is you must solve for y. Then you choose your values of x that you're going to use, and then just connect the points using your line, just as like how I described. Now when you think about it, you need to ask yourself, how many points do you need to graph a line? Really, you only need 2. You only need 2 points. And now let's move on to example 2. And now we're going to take a look at graphing using the slope and y-intercept. Now when we have y is equal to 2x minus 4, basically we have to rearrange the formula if it's not in the right form into y equals mx plus b. Then we have to plot the y-intercept and then figure out how far we have to go up and down. So let's do that for this problem so we kind of have an idea how it works. So we'll start with y is equal to mx plus b. This is what we're looking for. This is exactly what we're looking for. Our equation is already in that form. 2x minus 4. Now, in drawing this up, you'll notice that our slope is m is equal to 2. But what we want to do is we want to make sure that it's in rise and run form. So you know that m is really the same as saying 2 over 1, where this means move 2 up, and this means 2 to the right. Now, this point here, this number here, the 4, is talking about our b value, which is our y-intercept. So in order to find the y-intercept on the graph, we're literally just going to have to count up or down from 0. In this case, we're going to count down from the origin. 1, 2, 3, 4. There is our first point. Now, in order to get the rest of this graph, we actually have to use the concept of rise over run. So in this case, we said we have to go 2 up, count 1, count 2, and then 1 to the right, 1. And now we'll just fill in our final point. And so now when we graph, we end up with something that looks a lot like this. When you have done writing your graph, what I want you to do is I actually want you to actually write your equation for your graph on this chart so I know what you're looking at. Make sure you also label your x-axis and your y-axis on your graph. Now let's take a look at graphing using the x and y intercepts. In order to do that, you literally just have to let your x's zeros and your y's are zeros. So let's do that for this equation. So here's our equation. It's the exact same equation, it's just put in to the right form, into standard form. Now you'll notice I didn't specifically ask you to go and solve for y. All we're going to do is use our x-intercept and y-intercept calculations to accurately plot those points. So let's quickly do that. So remember, we'll follow the pattern we used before. So for our x-intercept, we let y equals 0. In our original equation, if we let y equal 0, this means that 2x minus 4 is equal to 0. So we'll solve for x. We'll solve for 2x. So we isolate 2x. So we get 2x is equal to 4, which means x is equal to 4 over 2, which means our x-intercept is 2. And we can quickly go and plot that on our chart here. X and y. And we'll plot that right there like so. And now we'll go and do the same for our y-intercept. So our y-intercept, we let x equal 0. And now our equation that we have here becomes negative y minus 4 is equal to 0. So we end up with negative 4 is equal to y. So our y-intercept in this case is going to be negative 4. So I'm just going to quickly plot that on my chart. And from here we end up just simply drawing our line that goes on forever. And we will also take the time to label our line. So 2x minus y minus 4 equals 0. And we're good. So now what I'd like you to do is I'd like you to practice these problems on the sheets that I've given you. Good luck.